This video is a quick review of some basics about complex numbers and imaginary numbers. So consider the equation x squared equals -1. Now I want you to think about this. Is there a real number that if I took it and I put it in the place of x and I squared it, I would get -1 as an answer? Well, we know that's not true because anytime you square a real number, you always get a positive. So this equation has no real solutions, which brings up the need for imaginary and complex numbers. So we're going to talk about imaginary numbers, which we call I. So I, it's a little lowercase cursive I, is defined as the imaginary unit, and it's equal to the square root of -1. So that means that if I take the square root of -1, which is I, square root of -1, and I square that, I get -1. So I squared is -1, which doesn't happen in the real number world. I cubed, using our exponent rules, would be I squared times I, but I squared is -1, so that's -1 times I, or just -I. I to the fourth would be I squared times I squared, but we know that I squared is -1, and -1 times -1 is +1. Complex numbers are numbers of the form where you have a real number part and an imaginary part. So the real number part A is called the real part of this number A plus BI, and the real number B is called the imaginary part of BI, and I is the imaginary unit. So we have a real number part and an imaginary part. So let's do some evaluating. Square root of -4. The first thing you do is you pull out the I, and then you have square root of 4. But square root of 4 is 2, so we just write 2i. Pull out the I, that's going to give you I radical 5, but the proper way to write that is square root of 5 and then the I. The I always comes last. Square root of -8, pull out the I, radical 8, and now I have to break that radical 8 down, and I can break it into a 4 times a 2, and then there's an I on the end. Square root of 4 is 2, so the correct way to write this is 2 radical 2i. Again, I'm moving that I kind of far over so you can see it's not under the square root sign. So here we have solve each equation. We're going to use the square root property here. And so I'm going to isolate what's been squared by moving the 9 over. This is a review of something we've done in the past. We have x plus 1 squared equals -9. I take the square root of both sides. X plus 1 equals plus or minus 3i. Pull that I out and then take the square root of 9. Subtract your 1. Be careful how you write it. X equals -1 plus or minus 3i. And that is in A plus BI form. For this one, I'm going to do things a little differently. I'm going to go ahead and distribute this and get x squared minus 4x equals -8. I'm going to add an 8 to both sides to get it equal to 0. And I have x squared minus 4x plus 8 equals 0. Well, let's see if it's factorable. Are there factors of 8 positive that add up to -4? Well, your choices are 8 times 1 and 2 times 4, or the negative of both. None of those add up to -4, so it's not factorable. I'm going to use the quadratic equation since it's already equal to 0. So A is 1, B is -4, and C is 8. That gives us x equals the opposite of B plus or minus b squared minus 4ac all over 2a, or x equals 4 plus or minus 16 minus 32 all over 2, which is 4 plus or minus square root of negative 16 over 2. Continuing with that, we can see that we do have, let me get this one up underneath here so you're not seeing that problem also. We do have a complex number because I've got an I here, so it's going to be x equals 4 plus or minus 4i all over 2. Now I can cross cancel by dividing each term by 2. So 2 goes into 2 once, it goes into 4 twice, it goes into 4 twice. Every term has to participate. So you end up with 2 plus or minus 2i. And that is also in a plus bi form.